Welcome back to VTU e-learning Shikshana program on computer aided engineering drawing. We are working on module 2. Today we will work on pentagonal pyramids in different orientations, particularly the axis inclined at 30° THP and 45° TVP or vice versa, or any angle for that matter, and also slant edge is inclined at some degree to HP, or the slant edge itself is on HP. Now let me take a problem. A pentagonal pyramid of base sides 30 mm and axis 60 mm long as a base corner on HP, such that the axis is inclined at 30° THP and 45° to VP. It can be appears to be inclined at some degree to VP, okay, or top view of the axis is inclined at some degree to VP. Let me take first problem on pentagonal pyramid as the regular problem, inclined to HP and inclined to VP, particularly axis. Then we will look into the other parameters. Now let me tell you what exactly the pentagonal pyramid, pentagonal prism, whenever you go through some question papers or the questions asked by your teachers, normally pentagon shape will be there. It is something like share, tiger type. Why I say this? Because of the mistakes we commit in preparing the initial position or preparing the pentagon itself. Now I will tell you how to prepare the pentagon. Now if I take a general information, pentagon is actually having one side with two more sides adjacent to that with 108 degrees interior angle, and all sides are equal, you know, and these two sides are again equal. That means you have to maintain 108 degrees while working manually and keep this. Now how to prepare this? Basically, first draw a line, then 108 degrees, 108 degrees, normally we commit mistake by taking 112 instead of 108, that is one mistake we commit. Then take these two as centers, draw arcs, then the same centers, these 2 points, and then same radius you draw. So that gets you this, fine. Now this is actually corner condition I am keeping, okay, let us think that type of orientations afterward. Now let me concentrate on the basics. Now start from naming A, B, C, D, E. Now this is top view of the base of the pyramid. Now if I take pyramid, pentagonal pyramid, you have base edge perpendicular to VP. A simple position I am showing. These are the base edges and these are slant edges for a particular height. Now if you look from top, you will get the top view as pentagon, even though base is not visible, boundary is visible, edges of the base and slant face edges are common. So that is why this is visible. Say. Next, what about top view of the slant edges? If you have to identify the center, that means you have to draw two perpendicular bisectors, preferably one horizontal and any other one. Even in computer you have to do this, okay, it never gives automatically, it gives automatically pentagon, not the center, okay, center you can identify, but you have to draw all these. Now how to complete the top view? Top view can be completed by using the dark line if necessary in that particular event. So dark line, then draw all slant edges. This is vertex and this is O. I always use VO, vertex V and O. Why you should not use OO1? You can use, but there will be a problem, confusion will be there, and do we end up with trouble afterwards at the end of the session, I mean completing the problem. Now this is V, this is O. So O is not visible and O, V is towards observer. Next, join all these corners. This is what we forget normally, okay, this is must. then fix the views, front view, top view according to the requirement. This is how you have to draw. Now, in this position how to draw the front view? Project all these points and project this also and fix the height 60 mm. Join the apex with all base corners. See, this is A, B in sequence I am getting. This is the advantage of keeping the left extreme corner as A, B, C, D. Next, this is E, then this is D. Join all these points with apex. Yes. Now, what exactly you have to do with this? What all to be marked? Dark line. Yes. As usual, we mark VA, VB, VC. Fine. Now, what about this? This also we forget sometimes. So, dark this base surface. Next comes the axis. Axis must be identified with the convention full line hyphen full line hyphen. So, this is how you complete the projection of a pentagon. Now, you see this also should be dark. So, I repeat, base edges must be dark, the slant edges must be dark. Normally we miss this and keep only OV and these two lines medians. Then O dash V dash. So, let me review. A, B, C, D are the base corners, V, O, V represents the apex and O represents the top, bottom end of the apexes, and this is the projection. So, I am insisting on this. Normally the mistakes will be in this pentagonal shapes, particularly pyramids. Now, if I take up this pentagonal pyramid for this particular problem, he says edge condition, that is the edge on HP, base edge on HP, sorry, base corner on HP, base corner on HP. So, this is base corner I am taking to the right side, preferably to the right side you take, particularly for solids. For laminae we take to the left side. Now, let me take the model and then explain this particular problem. First position, second position. So, why not this first position? As I explained earlier, in laminae as well as solids, this becomes edge condition. So, corner, again there is one more class there, condition. The corner must be placed in such a way that the perpendicular bisector passing through that point or corner must be parallel to VP. Then only once you incline this, the axis will be inclined to only HP, and these two base sides containing the corner and HP make equal inclination with HP as well as VP in this condition. But once you give inclination to VP, the inclination to VP changes, but these two will have same inclination with HP, equal inclination with HP. That is the basic condition. First position, second position. So, initial position is the axis inclined to HP. So, you make it perpendicular to HP to get true shape on HP, fine, you are getting the top view as true shape. Now, dimensioning and all is common, you must do it accordingly. So, whatever the dimensions given, you must keep it 30, and here with the specified thickness you have to keep 60. So, this becomes initial condition for the particular problem, first position. What about second position? Let me take this particular problem first. 30 degree to HP, inclination to HP only you consider and then do it. First position, second position. Here in case of prisms, already pyramids, I already told you, you cannot take the slant face or slant edge directly for this axis inclination, you take the base inclination. So, axis inclination plus base inclination equal to 90 degree. So, here the axis inclination is 30 degree. So, that actually base inclination will be 60. So, in computer what you do is you move and rotate this figure such that CA as reference you move by 60. So, that you will get axis inclination 30. In this case also manually you have to draw like this. First position is this C dash, you mark C dash, then draw a line inclined at 60 degree. Okay. So, because 30 degree is the reference, take 60 degree and mark these points. So, take with compass same distances, you must mark here. Suppose that if you take in this sequence, you must mark in this. If you do ulta, then problem starts. You never get the solution. Now, after getting shifted this here with the compass, then draw perpendicular line through O. This is O dash, this is B dash, D dash, this is A dash, E dash. Fine. Now, draw perpendicular. So, after you draw perpendicular, you are going to fix the axis at the given height. Okay. Say this is V dash, this is O dash. Join them. So, this is how you get 60. Then you measure, you will get 30 degree as required. So, let me complete first with the light line, or directly you can complete with the dark line only, no problem. But if there is any confusion, you can keep first whatever is available, you must keep it here. Check twice whether order is maintained. CBD, yes, then O, then comes AE. So, then only this becomes perfect. Then this is 60, definitely this gets you 30 degree. So, after you clarify this condition, then go ahead with the second figure top view. How to draw the second figure top view? So, first you keep the base only, do not draw all these projections up to V, draw only this topper, say using alignment indicator into computer, whatever the points you want, only that one you fix. Otherwise, manually also you can optimize your work by projecting only this, but do not project axis. This is most dangerous line. I will tell you why. Then V. Mark these points. This is A, this one is B, this is C, this one is D, this is E. Draw this lines joining all corners. Next, mark V. V. I have not marked projected up to this. This is only one line sufficient. Then keep this. All are light lines now. After this, you can see that the visibility concept, what are the lines visible, dark, dotted, etc. Suppose that you draw axis line only, axis line also first. Instead of D here, you will be marking here. Instead of B here, you will be marking here. And ulta, this one here and one more here. So, all these things will be there. I will show it on the computer how exactly possibilities are there easily. Already I have shown you, still I can show with this problem also. Now, at the end you can mark axis and mark. Now, which method you follow, key surface method or farthest point method or item method? I will tell you, I will give one clue for you, very easy. If you look at farthest point item, it is corner. All corners joining that invisible corner or item are within the boundary, then easily you can adopt farthest point method. Otherwise, if there is any confusion, number of lines are there, it is not clear, then you can go for key surface method. Key surface method works for all problems, but here it leads to confusion at the second stage. Here you can easily work. I prefer to work with farthest point method here. Now, C is the farthest point for you. Base corner C is the farthest point from you. Here you are here. that is not visible, number 1. Any number of lines joining this particular point are not visible. So, C is not visible and these 3 lines joining this particular item which is not visible or farthest item from U are not visible, that is all. Rest of the lines are edges are all are dark. Now, dark all edges, always boundary lines are dark, that you know. Now, irrespective of the positions, you can dark all other lines except these 3 in one go. Yes, this completes the solution. Okay. Now, I will repeat, if you look from this direction to complete the second figure, top view, C is the farthest item from U, that is not visible, and any number of edges, either slant edge or base edge, connecting to that are not visible. So, hidden lines. Rest of the lines all are dark, and see that all boundary lines are dark, that is always there. Okay. Next, we have completed all edges, visible, invisible. Then what about axis? But there is little scope for axis representation here. Already hidden line is occupied this portion, and O to C you can mark, that is only representation by the full line hyphen full line hyphen. Okay, you can use 0.25, 0.35 in computer, and what best you can do is you can zoom that area and then remove whatever line available, then replace that or modify that. Suppose that if the continuity line is there, then you have to go for split, otherwise you use trim, then you keep these 2 out, then you can replace that with the axis. So, this is how we can complete the top view, second figure top view of the problem. Next comes the axis, again is inclined at 45 degree to VP. So, what best you do is you realize that OV of second figure top view is its true length. No, because already it is inclined to HP, it is already become apparent length. So, you are supposed to keep this is apparent length, you will get some value. True length is 60, apparent length will be less than that definitely. Now, you are supposed to find beta. Why you have to find beta? OV is apparent length, AL on AI, apparent length on apparent inclination, that is beta. So, find beta. So, this is how you can analyze the given problem, whether to find beta or not. Now, after completing this figure, now how to find beta? You can do it separately or here only, but here if once you are start rotating, then there will be some confusion or the angle shifting and all will be there. I will show you on computer how exactly you get problem. Now, basically you are supposed to work for finding beta. I will show you how to find beta. This is V. Always I prefer to take the base towards observer. Then 45 degree is the line, draw 45 degree line, take true length of the line. Okay, true length of the line you take. Then this is V, this is O of true length, OV of true length, this one. Next you take apparent length, mark, then this is O of apparent length, apparent length will be marked, then gets you the. So, on this line, beta degree line, you have to find the, you have to place this VO of second figure top view, that is all. This is phi, this one is beta. So, you have to replace this. So, now let me, since it is simple geometry, I can always draw this figure. You have to redraw this figure. How to redraw this in computer? Select this, move command, particularly V you move up to this, then you rotate about V only till it this VO coincides with this point, okay, O of apparent length, then you will get the final solution. Suppose that if they give appears to be inclined at 45 degree to VP, directly you take beta equal to 45 degree and draw the figure. Or top view of the axis is inclined at 45 degree to XY. If they say top view, they will address to XY, not VP. Okay. Then also beta is given. Okay. This is how we can complete the problem. Now let me draw and then show you how exactly you will get the solution. Now assume that I am working manually with the computer, you know, move and rotate. Here what exactly we do is, let us keep this O as reference and mark these points better. Let me, for geometry replacing purpose, redrawing purpose, we will keep it N and M. Now mark this here N, M and C, that is all. Then through that you draw perpendicular lines using small protractor or any set squares. Then you are supposed to take this is C, directly you get. You are supposed to take only two distances and mark all the points. See, let me take MD equal to MB, you mark from this O, okay, not mark from M. So MD, MB, then you take this EN equal to NA, that is all. So you will be getting these points. Now draw light lines, say, okay. Now join these points. Okay. Assume that I have redrawn the same figure and dark the same. Whatever is available here, let me draw. Okay. Now name these points as available in the second figure top view, C, D, this is E, sorry, this is E, this is A, this one is B, already C is there. Now dark all this, okay. Now let me check VA, VB, VC, VD, VE, all are available. Whatever is available, I have redrawn this figure such that VO is on beta degree line. So this is basically 30 degree, okay. Now again you have 45 degree inclination, then you will get beta equal to 55 degree if you measure, that is what we used to get, okay. So now you project it up, project the same towards the front view and get the all points ready. Now let me mark C on exactly on XY line because it is on ground, C dash. Next point is BD, BD, this is B dash, this is D dash. Then AE, unnecessary lines you can avoid by keeping this is E dash, this is A dash. Every time you check twice whether you have made it properly. Now V finally, before that let me join this to avoid any confusion, okay. You may get the variations D this side, E this side, or because of angle changes. Here I have taken approximate angle and drawing. Now V, mark V, okay. Now so join all corners of the pentagonal base with apex. This is again refers to the key surface reference or the farthest straight line. Let me take farthest point only and check. See, V is the farthest point from you, V is not visible, fine. Normally we say all edges which are joining V are not visible, then there will be always confusion. Say okay, E dash V dash and B dash V dash is not visible. No, boundary lines always visible. So now we confirm that E dash V dash and E dash B dash are visible. What about V dash A dash and V dash D dash and V dash C dash? All confusion we get. So for that, what best we can do is, or somebody may say if you look from this direction VB is visible, VA is visible because they are nearer to the observer. That and all we can clear by key surface method. So which key surface is visible? Key surface, see first position, yes, first position, second position. I have taken base towards observer. Base is, I have made it yellow purposefully, dark color. First position, in first position base is not visible. See, I will tilt by 90 degree. Base is not visible. Assume that is top view for you. Next, next case also base is not visible, that color is not visible to you. Now what I do is, after first position, second position, I am keeping like this. See, base is towards observer. Suppose that if I keep it like this, again base is not visible, base is away from the observer. Now that case also I will show you on computer how it looks like. First position, second position, third position. Now base is visible. So key surface, there are two key surfaces in prism. In pyramid we have only one key surface, that is visible now. So procedure is very simple and easily you can understand. Draw all edges of the visible key surface, that is basic procedure 1. Draw all visible key surface, that is the only criteria you need to complete the show. It is very easy. We do not need any other orientations. Which is the nearest key surface, whether key surface is there or not, that also we will take. Key surface is there, definitely its base is visible, dark. Now all boundary lines are dark. Yes, all boundary lines are dark. Next, invisible key surface is not visible. So no invisible key surface because we have pyramid apex, then drop that procedure step. Then go to the two easily understandable item is visible bends, invisible bends, or visible surface, invisible line, invisible surface, visible line. This is fundamental concept, basic concept. See, this is invisible, visible surface, any number of edges crossing that are not visible. See, for example, in this case there are number of edges here, black red, dark red color, this is yellow. Now you can see only yellow surface, not the edges which are back side, okay, just behind this, okay. So visible surface, invisible line. So here invisible surface, visible line. Suppose this surface is not visible, these edges are visible, slant edges, okay. So that is how you can complete. Now visible surface, invisible lines. Okay. So one more line left, that is AV. AV, what is about AV? Whether it is visible or not? It is visible because of this bends. Because the surface is visible, definitely A dash, V dash is visible. Okay, or otherwise one can say this is very near to the observer. That and all is, you must have imagination. Otherwise, it is difficult. This is best. Visible bends, invisible bends. This is A dash, B dash is visible because of bends. This two are visible. Any line, number of lines joining, normally 3 lines joining a point in this type of problems. Definitely these two are visible, this is also visible. That's enough. Okay. Now this is how you complete the solution. Now add the axis also here. It is very important for all solids. Keep axis represents. Okay. Suppose that they ask axis appears to be inclined at 30 degree to EP etc. Again 45 degree to EP, then you take directly beta equal to that I told you already. Now there are 2 more cases. Slant edge containing the corner HP is inclined at 50 degree to HP. What you do is, this becomes, this is your slant edge, okay, slant edge, and this will be placed on ground if you rotate with the axis reference. Assume that this is the reference for you, okay. Now you can directly rotate. In computer what you do is, you can directly take this figure, move, and then about this point you can rotate, but how much you rotate, you have to calculate all this. For that what you do is, draw a line initially 50 degree or whatever given, I have given 50 degree, okay, then rotate and see that this line is on that particular 50 degree line, that is all. Then do not worry about the axis. Here axis I had mentioned, in that slant axis, slant edge method, you mark this is 50 degree. So again this type of problems you can solve. Rest of the procedure is same. Okay, then they may say axis inclined at some degree to HP. Yes, you see that axis already inclined to HP. Once slanted is inclined to HP, X also assumes some inclination. Anyway, it is inclined to HP. It assumes apparent inclination. Then take again beta. Not necessary that slant edge only should be given for the apparent angle. Slant edge only can be given. This is inclined at 50 degree and some degree to VP. Then the slant edge also has been reduced, that is apparent length. With this apparent length and this true length, you find beta. Normally they refer to axis, or they give appears to be inclined at, or top view of the axis inclined at some degree to be, you take accordingly. Then finally slant edge on HP. So instead of some inclination, what they do is they give question like this. They slant edge, you rotate this particular figure in second figure front view such that C dash V dash is coinciding with, this is C dash, this is V dash, is coinciding with XY line, that is on HP. So again the same type of question can be asked. Instead of inclination to VP with the axis, they may give the slant edge itself on HP is on HP and inclined only to VP, then apparent length, apparent angle will not be there, true length on true inclination. This type of problems we will discuss on computer. Let me take a problem on pyramids. A pentagonal pyramid has its base on HP such that a base side is perpendicular to VP. In this case, we have pyramid base on HP. So the top view will be the pentagon. See, just observe here, you have a base side perpendicular to VP. Yes, I kept AE perpendicular to VP. Whatever you do here, that is for VP. I have kept the base side AE perpendicular to VP. Then this is the top view. Now if you draw top view of the base, that is pentagon, and project all those on to XY line. Next, fix the axis height and then join all corners of the base projection with V dash. That becomes front view, this is top view. Now there is little problem with the top view. The problem is we have not considered the slant edges. Whenever you keep the pyramids, you get slant edges joining base corners with V. So just observe in the last figure. So we have AV, BV, CV, DV and EV. So normally we end up with this, okay, assuming that the work is over. See, I have not taken AV, BV, VB and VC, VD, EE. So finally we have to work with this figure, that is AV, I repeat, VB, VC, VD, VE all are slant edges and base edges are AB, BC, CD and ED. Now joining all those corners in the front view gets V. So this is the final projection of this particular problem. Next, let me take a problem which is having axis inclined to both the planes. Now a pentagonal pyramid of base sides 30 mm and axis 60 mm long has a base corner on HP such that the axis inclined at 30 degree to HP and 45 degree to HP. Whenever axis inclined to both the planes, we have to think of apparent angle, that we will see further. Draw the projection. Now as I said earlier, this is the top view. Whenever it says it rests with its base corner on HP, whenever you have the odd number of sides with the particular figure, you should have the corresponding opposite side to the corner to be placed on HP perpendicular to VP. Yes, otherwise the perpendicular bisector of the base pentagon should be parallel to XY line. Next comes the front view. So front view is fix the axis given 60, join all corners of the pentagon and you get this. Now you see that the axis convention is to be followed. Next, he says the axis inclined at 30 degree to HP. So you have to think of inclination to the HP first, then whenever axis inclined to HP, you make it perpendicular to HP to get the true shape on HP for the base, that we have done. Next, you have to move and rotate to get 30 degree to HP. You know how to move it with the selection of this with the side, so that you can place the solid on the corner C. So, in fact, in this figure it is C dash in front view. Now, how to do it? I will just show you. I have to do this job. You have to give inclination to the HP either 60 to the base or 30 degree to the axis. In case of prisms, we try to have parallel line with respect to axis. If we give inclination to the slant edge, here it may not be equal to the axis inclination. So, what I do is I follow this axis inclination plus base inclination equal to 90 degree, and better you find base inclination, so that you can rotate about the base. Now, I will rotate it. We will show you how to do this. So, select this and then rotate. See here you have the facility. Now, select the base reference, and if the axis is inclined at 3 degree, definitely base is inclined at 60 degree, 60, and you see that this is inclined at 60. Now, check for the axis. Whatever the reference you take, better you take always the final one and check whether you got the required inclination. Yes, I got required inclination 30 degree. So, this is how you can incline the solid with respect to the HP, with respect to the axis inclined at 30 degree to HP. Now, that is what I have done here. Okay, inclination to the base is 60, definitely you will get 30 degree. Now, what you have to do is you have to project it. So, in case of pyramids, you always project only base surface, okay, and then get the corresponding points. Then only one line will do to get V. Do not project all items, all corners up to V reference. Here, see, I have done this V separately and then projected all corners. You can even use alignment indicator to get these points. Okay. Otherwise, you draw one particular lowest projection line and then V and also C, then complete this, then work for the corners. Next, join all those points. Now, see the visibility. Okay, what are the visible edges? Now, you can use two methods. One is the visible surface method or visible key surface method or the farthest item from this. Particularly, this particular figure is very easy if you use farthest item from you. Why? Because farthest item from you, assume that you are here to complete the top view. Here the farthest item is corner C. So, the corner C is not visible and any number of lines connecting to that are not visible. Definitely these three lines are well within the boundary. Definitely you can choose or select the farthest item method. Now, what I do is I will make CD, CB and CV all dotted line. Okay. So, because they are not visible. Sometimes I have been telling you, in case of pentagon, if you project axis first, then it may lead to mistake. Now, instead of this point, you are going to select this point. So, suggestion is do not project axis first. See, in this case I have not projected axis, safer side, I projected only B and D. Suppose that if you project axis, there may be mistake here. You will be selecting both these points or one point here and other point same. So, here this is also not correct. Definitely the axis should be projected complete after completing this job. Now, mark O. Now, completing this, as I told you earlier, farthest item from the observer is base corner C, the edges CD, CB and CV are not visible. That is why I have made it dotted. Next, boundary lines dark, completely boundary lines dark. All other lines are dark because in this farthest item method all remaining edges are visible. So, normally we check for boundary lines, all are visible irrespective of the situation. Now, this completes the job. There is a little space scope for completing the axis. See, OV is the axis, we have to represent with the axis, but already CV is covered by dotted line. There is a little scope for axis representation. Okay. So, we will discuss that. here see I have made this axis, convert that into axis convention. Next comes the axis inclined at 30 degree to HP and 45 degree. Definitely axis OV is inclined to HP and VP. Definitely OV of second figure is reduced, that is apparent length. Whenever you get apparent length on apparent inclination, that is you have to find beta. So, how to find beta? You know, you take the true length of the line, that is axis 60, okay, 60 V O1 of true length, O of true length is 60, and you take this distance, draw an arc on this locus. Definitely you will get the value of 55 degree. Now, you take this, move this up to this, V coincide with this and then rotate. Otherwise, you separately find out this and then directly you can take CV, I mean OV on 50 degree line, 55 degree line, that is this one 55 degree. You can do here also, but you can avoid confusion by working out beta outside somewhere here and then directly take 55 degree and place that OV on that, you know how to do it. Then how to get the final front view? Project all these points, only base corners with this base, previous base corner of the second figure front view, then get the corresponding value along with V. Now, how to complete this? Again you can think of the visible surface method or the farthest item from you. Farthest item is V, so confusing because V is not visible and related connecting to that all are visible, it leads to confusion. Best method is the key surface method. Base is visible, definitely base edges are visible, then boundary lines are dark. Just see here I have made all base edges dark. Since observer is here, base is nearer, definitely base is visible, base edges are visible. Then boundary lines dark, yes, you have made boundary lines dark. Then what about C dash V dash and D dash V dash? C dash V dash and D dash V dash are crossing the visible line, that is why it is crossing lines different pattern, that is dotted line, or visible surface invisible line, crossing line or visible surface invisible line. Definitely these two are dotted lines, yes, dotted lines, and see here dotted lines. Next comes this, that is OVA. VA is definitely dark because this is bends. A dash V dash is visible because of bend, because these two are visible, definitely one more line joining that also visible. So, this is how you can complete without any confusion. So, this is the complete solution of the problem, and just for understanding purpose, the visible key surface is base, I have made it highlighted, shaded. So, this is how you can complete the problem on the pentagonal pyramid with its base corner on HP with axis inclined at 30 degree and 45 degree. So, there may be the directly they may give it appears to be inclined at 45 degree to instead of directly giving, then you take directly OV on given angle 45 degree and remaining procedure same. Next, let us have the problem base nearer to the observer, base nearer to the VP, here base nearer to the VP. How you can get this? See here in this case, as I told you earlier, base is nearer to the observer, here base is away from there, base is not visible. So, first get the complete projection with light lines. Now, procedure is base corner E is the farthest item from the observer, and check the lines joining that particular corner are well within the boundary. If so, you can always choose the farthest item, otherwise visible key surface method. Let us work with the farthest item method and then check with the visible key surface method. Now, you can see E is not visible because E is the farthest item from the observer. If you draw a line, extreme line, it passes through E, okay, that is the farthest item from you, are very near to XY line. So, E is not visible, E dash A dash, E dash V dash, E dash D dash, these three lines are not visible. all remaining lines are visible. That is what, very easy job. Otherwise, you can say boundary is not visible, I mean base is not visible, next procedure is boundary lines dark. Then comes the invisible key surface edges other than boundary lines are dotted. Yes, these two are dotted. Again this becomes bends, invisible bends. See, just observe here, farthest item method, E, A, EV, ED all are not visible because E is not visible. Then remaining, all remaining lines are visible. Yes. So that is what. Then keep the axis. Yeah. This is how you can complete the problem on pyramid when base is nearer to the VP. Next comes the same pyramid of 30 mm side, 60 mm side has a base corner on HP, same condition such that the slant edge containing the corner on HP is inclined at 50. Instead of axis inclination, he has given this line inclination to this surface, okay, not surface, this is actually slant edge. Suppose if you do ulta, if this comes here, then there will be a problem on surface. Here this is a line reference, that is edge. That edge, slant edge is inclined at some degree to HP. So how to do it? You move as usual, then you rotate this figure such that C dash V dash is coinciding it here. First you have to fix the angle 50 degree line, then rotate. Okay. Next the same thing is worked out here. Now just observe, I have made this rotate here till it reaches V dash C dash. You know how to use rotate option, then project it. So the same concept, farthest item from you is C, C is not visible, C connect, any number of lines connecting to C are not visible, then all remaining lines are visible. This is how you can complete the visible line, invisible line, concept of visibility is over. Now same thing, the axis inclined at 45 degree to HP. So here the slant edge containing the corner on HP is inclined 50 degree to HP. Whenever you do this here, you just observe the axis, axis also assumes inclination to HP by some value. Now let us check how much it is, let us not worry about it, here we do not want that number, still for curiosity let me take, see it is inclined at 27 degrees. So original problem may be the axis inclined at 27 degrees to HP and 45 degree to HP. Definitely you have to find out beta, okay, with respect to axis, because same entity is inclined to both the planes. Definitely you have to find beta, that is slant edge VC is inclined 40 degree, that is in second figure front view. V dash C dash is a line inclined at 50 degree to XY line. Yes. Then the VO, see here VO is a line inclined at 53 degrees, so we have to find beta. So the axis inclined at 45 degree to VP. In second figure front view, top view, OV is apparent length, OL, AL on AI, that is apparent length on apparent length, that is find beta. That is how you find beta. Then you take this measurement, that is 53.36, actual value is 60, 60 and 53.36 you use and do this job, otherwise you keep outside and then finally use 53 degrees. You keep VO on 53 degrees and then project. See, this is again normally we take base on HP, base nearer to the observer, you can also take base away from the observer, same type of augmentation. Now if you project this, you get the final figure with light lines. Now base is near to the observer, base is visible, okay, then boundary lines visible, the D, V, CV are not visible, AV is visible. So this is regarding the surface method, that is what we have to do, because V is away from the observer and farthest item there will be confusion. So normally we, in this situation we take the visible key surface method and complete, or check with the other also and see that the boundary lines are dark always, okay, and visible surface, invisible lines, crossing line again, and this is bends. Next comes the respective problems on the pentagonal pyramid. Pentagonal pyramid, base side 30 mm and axis 60 mm as a slant edge on HP. Instead of having some inclination, it is completely resting on HP. Okay. on the top of the axis inclined at 45 degree. It is something like appears to be inclined at, axis appears to be inclined at 45 degree to, okay, that is beta is given. Okay. Next, another version is a pentagonal pyramid of base edges 30 mm and axis 60 mm long as a slant edge on HP. The axis appears to be inclined at 45 degree, that is what I told. You can have this axis appear. Otherwise, there is one more version I will tell you once I complete the solution. Here I have given the corner condition with respect to HP, you should have, then only you get slant edge reference, either it is inclined to HP or on HP. Okay. If it is slant face, then you can have slant edge condition. Now, let me keep this here. So, how to do this? It is very easy. Now, I will show you how to do it. Now, you select this and then rotate, move first, okay, move, yes, see that this is on that XY line, then take the rotate command, rotate command, and then you have CS reference, and you not keep V, can extend it, otherwise you can keep V reference, then see that it is again touches XY line, see this is blank. Now you see VC is on HP, okay. So similarly you can have VC inclined some degree to HP, that is the slant edge is inclined at some degree to HP. You can take same rotate as we did in the previous case. Suppose that this is, I am considering this is 50 degree, yes, you can click here and then do it. Assume that I have drawn already line, then you can click here, okay. So this is how you can do that job. Now let me have this as the second figure, front view, okay, as the slant edge VC is on XY line, that is on HP. Now you have to project this and get the base surface, and then only one line will do for V. Now that is what we have done here, see this is done, and then here if you look from this direction, base is visible, okay, base is visible. Visible key surface method is best here to avoid any confusion. Base surface completely is not true shape, it is visible, and this is visible, then boundary line is dark, okay. So let us say the boundary line is dark, then E, V and AV are visible because bends, visible bends, okay, see here, and also the CV is not visible because it is crossing the visible surface or crossing line, okay. This is how you can do it. Now you can have the axis appears to be inclined at 45 degree, definitely you can take the axis inclination to 45 degree directly, then see you move and rotate, then if you look from this direction, base is visible, okay. So first draw the light lines for the projection, then if you look from this direction, visible key surface dark, see visible key surface dark, then boundary line is dark, yes, then comes BV, BV is bends, you can, these two lines are visible, definitely this line joining that also visible, bends, and then and also DV and EV are dotted line because it is crossing the visible surface or crossing lines, yes, this is visible and this is crossing line. Now final solution is this. So I will just give one more version of the problem here. We can refer to directly the slant edge on HP instead of VP. You can give information to the axis, I can give directly to the slant edge. The pentagonal pyramid of base sides 30 mm 60 mm long has edge on HP as a slant edge on HP inclined at 45 degree to VP, directly you can give, you need not give axis inclination. The axis on HP is CV. CV is again, do not refer to OV, let us concentrate on CV, is true length and true inclination. See, CV is parallel to both the planes, it is inclined only to VP, definitely the CV is inclined only to VP and on HP and inclined to VP. So, definitely this is the problem, or another version of the problem. Pentagonal pyramid has a slant edge on HP inclined at 45 degree to VP, that also we can do. So, this is how you can complete the problems on pyramids, particularly when the slant edge on HP or slant edge inclined at some degree to HP, or axis is inclined at some degree to HP and some degree to VP. So, in coming sessions we will work out the problems on hexagon and related items.